Hi everyone. Our next speaker is Professor Dagan from Ilan University. Ido will be talking about consolidating and exploring open textual information. Thank you, Ido.
Good afternoon. This talk, maybe somewhat in contrast to the previous one, will be describing more the general research line we are engaged with in the recent years. So I'll be discussing both kind of recent work and work in progress. It's going to give you some overview of some of the, or I would say the main directions in which my group at Bar-Ilan is engaged with. And this work is kind of a research line, so as you can see, quite few students involved and quite many collaborators. Specifically, I'd like to give credit. It's difficult to move, but can you hear me if I point a little bit? So I'd like to mention Ori Shapira and Ilan Klein, two PhD students that are leading much of the research currently, the current stage, the current kind of round of research in the directions I'll describe. Ori works more on the exploration, summarization aspects. Yeah. And Ayal on the representations, semantic representations. You'll see it along the talk. I'd also like to mention, since this is an Intel organized event, I'd like to mention that we are also collaborating with a group at Intel, at Intel AI Product Group, and we also have some funding from them, so it's part of this research line. Okay, so the main story we are interested in is dealing with information that appears in multiple texts. Because for almost any topic of interest, the information we are interested in appears not in a single text, but in multiple texts. And while much of the NLP literature deals with handling a single text at a time. And the question is what you can do when you have multiple texts. And as humans, when we see information in a lot of texts, it's hard to comprehend it. You have to skim and look for your information. What we would really like to do, and in a sense what we are typically doing manually, we go through the text, we identify different pieces of information, and we try in a sense to consolidate, to see that right, some piece here is the same as another one here, and maybe these two are related and connect to each other, and gradually we are building a picture by going through multiple texts. What we would really be happy to have is some automatic mechanisms that could identify this kind of, perform such consolidation of information across texts, and eventually maybe give it to us in a consolidated way, in a summarized consolidated way, and this maybe would actually what's called a summary, right? And there is a traditional task in natural language processing, in NLP, which is called multi-document summarization, which addresses exactly this task. The input is a set of text, and the output is a concise summary. And similarly, this satisfies our need. But to a large extent, not really. Because if the user is really interested in the information, then typically the information in the summary would not suffice, would not be enough. And the user would like to know some more about the topic of interest. And to search more, to go beyond the summary, means you're now thrown back to the original text, and you have to find your way through this text again. Okay? This is what we call the summarization summarization gap between the information in any given summary to what the user really wants to see. And a possible solution for that will be interactive summarization. If we could somehow interactively expand the summary according to the user needs, but already give consolidated, summarized information, that could be much more useful. Okay? So this motivates one part of our research. How can we help people confront with multiple texts? And the direction is to move on in NLP from static summarization, which is what everyone is working on these days, to interactive summarization. The question, how can we develop such paradigm? So just to give a sense, I'll show a quick demo of a current prototype system we are working with. I already opened it. Okay? So what you can see here is kind of a very preliminary prototype system, still unpublished, which given a set of documents, in this case it's a set of documents about affordable housing in the US. And to start with, we get some summary, right? So you can see here about something in the history and what someone is saying about housing crisis, etc. And we get a short summary, the standard multi-document summarization method. But as we read, we might want to find some information. For instance, we see that there is this person Cuomo that's probably prominent in this area. I would like to know more, what's else in this text about Cuomo. We can highlight, look for more information, and then see that this Cuomo is actually the housing secretary and refer to what he's talking, okay? We might want some information that's not presented yet. We want to learn more. So we might be able to get here maybe some suggested queries that will tell us what else can you find in this document that we haven't shown yet because it's a short summary. Maybe I'm interested to know about the impact of affordable housing on the working poor, and then I can get some more information about what these documents say about working poor, about Republicans supporting them, but maybe eventually the policies don't make an impact on the working poor, etc. I could type my own query. I could just expand the summary a bit more. I mean, at some point, I don't know what to look for next. I just want to expand the further summary. And this way, I can actually explore the content of the documents. So this is something we would like to enable. This is something we would like to investigate. Okay, so this, I think, gave you kind of a sense of what kind of technology we would like to develop. Okay. And there is an issue, a technological issue, about which I'll talk in the second part of the talk. How can we enable an effective summary? The summary that I showed you so far was what is called extractive summary. You could see that actually the summary was composed of sentences, like key sentences, extracted from the original documents. But often maybe you want to merge, take just some sub-pieces of sentences, merge them together. So we would like to consolidate the text in a more fine-grained level, and particularly interactive summarization. Maybe we ask for a certain detail that's only takes part of a sentence, and maybe to answer the query, we want to take two pieces from different sentences, two different documents, and put them together. So somehow we'd also like to support such interactive summarization with much more fine-grained semantic representation and consolidation of the original information. Okay, so these would be our goals. And accordingly, I'll divide the rest of the talk to two quick overviews about two sublines of research. One is about the interactive summarization, and mostly how we can establish it as a valid research paradigm, and I'll get into that. Evaluation is a very big issue here, because we are in academia, in a research environment. We need some numbers to report. And also talk a little bit about the initial implementation that I just demonstrated. And in the second part, I'll just say a little bit about how we are working now to approach this more fine-grained consolidation. So for now, we just work with extractive summaries, with state-of-the-art summarization, but at the same time, we try to improve our semantic infrastructure so in the future we can provide even better summaries. So these are the two issues. So let's talk first about interactive summarization as a research paradigm, not just as a system. Okay? So in order to think of interactive summarization, how we can formalize it better, we can see that in interactive summarization, we get some initial summary, and we'd like to gradually expand it, either getting deeper or getting broader along the way. Okay? So a way to abstract that would be to notice that after I've seen an initial summary, I made some interaction. I made the first interaction. Okay, I had the initial summary. Now I made the first interaction, and the summary with the user and the summary expanded, right? I have what I had before, and then something was added. And then there is another interaction, and the summary gets added, and so on and so forth. So in effect, the first observation is that we can abstract an interactive summary as a sequence of incrementally growing summaries, right? If we assume that in a 5-minute session, the user hasn't forgotten anything, what we have at the end of the session is actually, or at each point of the session, is actually kind of a cumulative summary of whatever the user has seen so far. That's actually the information that the user could consume until that point, okay? So this is the abstraction we would like to make, and then the question, how can we evaluate it? Because the evaluation methods that have been established in the summarization literature in NLP for a couple decades deal only with static summaries. okay? But now this abstraction, we can actually give us a way how we can extend the static summarization evaluation methods, static summary evaluation methods, to interactive summary evaluation. And this is important actually because from my introduction, one could ask, you could ask yourselves, how does it happen that for 20 years the community is working only on static summaries or almost only on static summaries and not on interactive ones? And in fact, in the last couple of decades, there were really a handful, that's all. In NLP literature, you could just find a handful of attempts to provide interactive summarization systems, but the way they were evaluated is by user studies. So you let people work with the system, and there are some typical questionnaires for checking user satisfaction. But then if I want to compare this system to that system, you know, that shows up a year later in another conference, how can I do that, right? Most tasks we are dealing with in NLP, we'd like some numbers that we can compare from paper to paper. And this should apply both for automatic evaluation measures. So in summarization, we have both automatic summarization measures to allow systematic comparison and fast development cycles, but the automatic measures are not considered reliable enough. That's why very often in summarization papers, it is expected that you'd also do some manual evaluation. And we'd like to have both also for the interactive setting. And what we suggest is actually to follow evaluation measures for a single static summary and adapt them to the interactive setting. And the way to do it will be actually quite straightforward. Since we said that an interactive summary could be abstracted as a sequence of incrementally growing static summaries, right? We can evaluate each snapshot with a typical measure and actually get such a graph, right? This is the quality of the summary, and we are talking about recall-based measures. I'll elaborate in a minute, people that know Rouge, for instance. These are pretty much measures that check how much useful information have you put in the summary. And as the summary grows, you expect that I'll be able to put more and more useful information. So there is some kind of score which measures the value of the information that you've proposed, while the x-axis is actually with a point for each interaction round. So each such incremental snapshot will be another point on the x-axis. And this will actually give us some quantitative evaluation for the effectiveness of the summary at each point. And if we want a single number, we can take, for instance, the area under the curve and get a single measure to complete the effectiveness of different systems along the whole session. Okay, so that's the approach we are going to take. So just a couple of words, just to give a quick sense how we would like to do it. On one hand, we would like to do it for the Rouge measure, which basically checks a system summary by seeing how much of the content of a reference summary it covered. So the typical methodology in summarization is to let people write reference summaries and compare how well the system summary covers the content of reference summaries. And in Rouge, it's just measuring that with n-grams, so it's somewhat shallow, but it can be done automatically. Okay? Now, to do that, we had to overcome a very traditional hypothesis that has been in the community for 20 years almost, that in order to evaluate a static summary, you need a reference summary of the same length. And in the interactive setting, it's not realistic to assume that you'll collect reference manual summaries for each length. That's why we had a work at last EMLP showing that you can actually get along with a single summary of the same length to evaluate system summaries of multiple lengths. This was actually, we assessed that by comparing a correlation to reliable human evaluation. That's a common way. And basically the value of that is that now we actually suggest to the community that even with static summarization, people can now evaluate different lengths. I mean, think of it, even with a static summarization system, it is always perceived that if you provide such a system, you should have some knob that can say, now I want a 50-word summary, a 100-length summary, a 200-word summary, while the literature for almost 20 years was always evaluating on a single summary length. So even in static summarization, this opens up more opportunities, but in interactive summarization, it means we can evaluate each snapshot and get these curves. Okay, so this will actually allow us to start evaluating interactive summarization in a consistent way. For manual evaluation, there is I mean, the reason, as I mentioned before, in summarization, people do automatic evaluations, which are typically at the lexical level. But in order to get more reliable evaluation, they ask humans to evaluate the summary. And they assume that people understand the meaning, the meaning of the content, and can more reliably compare, let's say, a summary to the original document or to a reference summary. And the point is that with manual evaluation, there has been some methods which are not that reliable. I'm not going through all the weaknesses. But the point is that they are crowdsourceable. So if we do nowadays manual evaluation, we'd like to be it crowdsourceable. So even for interactive summarization, we'd like to have a crowdsourceable evaluation method. The reliable method in the evaluation, in the summarization community was called Pyramid. It's basically similar to Rouge, but instead of comparing n-grams, people really extract like small statements from the reference summary and then check system summary how well it covers. So the semantic judgment is done manually, it's much more reliable. But it was extremely expensive. It's still considered the most reliable evaluation method, but it was abandoned a few years after it was introduced, like 15 years ago. What we have done here, we have developed a light pyramid method that allows to do kind of a light version of the pyramid in crowdsourcing. It's more sampled rather than exhaustive. The task is semantically easier. The guidelines turn to be just few simple lines, and it can be crowdsourced. And that's a paper we had just in the recent NACL showing that we can get much more reliable evaluation using this light pyramid method that can be a basis for comparisons. We see we get better correlations with the original pyramid, and we also see that it's much more stable. I mean, with some of the methods that are used today for crowdsourcing, people reported 24% variance for system scores in manual evaluation, while with the light pyramid, which is much more consistent, we get something in the range of 10%. Okay? So at this point, what we have basically established, maybe I'll skip that one. I mean, also we, again, propose to use this method also for manuals, for static evaluations, for the broader community. But for us, basically, it means that also we can take these snapshots and also conduct manual evaluation over them. So the takeout from that is basically that we propose that interactive evaluation that until now was hardly addressed and only evaluated by user studies that are really make it hard to compare. And that's why one of the reasons why people didn't get engaged with that can be evaluated in much more systematic way, just like there are dialogue systems that are interactive, but people have created data sets that allow systematic evaluation of dialogue systems. Okay, so that's the message here. In the time left, and there is some future work to do, additional aspects, etc. Okay, yeah. Just to mention, I mean, the way we start formulating, working on interactive summarization is through this demo I showed you, and this demo actually suggests that we can start working on interactive summarization through an approach that we call query-focused summary expansion, right? As you've seen in the demo, we get an initial summary, and we can let users different modalities of inserting queries, highlighting, putting a free text query, highlighting something in the text, choosing from suggested queries. So this approach suggests that to start addressing interactive summarization, you don't have to start with very complex systems. Already, if you just take the sense that what you need to have is a new summarization task, which we call query-focused summary expansion. Here is a summary, here's a query, how would you best expand the summary? It's a very isolated and well-defined task. On top of that, we can build an interactive summarization system like the one I demonstrated. So that's the directions we are now investigating and try to develop algorithm for query-focused summary expansion. So I'll just skip the rest. I mean, it relates to previous work, to future work, but I'll skip that. Okay, so that's the message about summarization. In the little time left, I'd just like to give you a quick sense of the direction in which we are working, kind of a parallel direction, whose goal is to provide better semantic infrastructure that will enable in the future to provide more fine-grained, more accurate summaries. Because summarization technology for today is quite coarse-grained and not sufficiently reliable. That's why the way you think about it, I mean, we see that we can ask questions at Google and get concrete answers. We have translation, but summarization we don't really have today yet operational in most kind of web applications because it's still not good enough. So the second part partly aims to make summarization more fine-grained, more reliable. So here's the approach that we would like to take, okay? We have the set of input texts. We are aiming at consolidating the information. But as we've seen, the consolidation means taking some piece from here, matching it with some piece from there, and another piece from there. So to do that, to do this matching, we first need to decompose each text to its minimal information units. So that's the first step we address. Once we manage to decompose text to like minimal information units, we would like to link them to tell that this piece is equivalent to this one. Maybe this one complements that one, okay? So we have here a linking stage, and based on this kind of linked consolidated text, we would like to generate eventually the summary, whether static or interactive. Okay, so that's the approach. So just to give an illustration why this is important, very quick one, suppose we have these certain sentences, each taken from another text, and we want to summarize them, okay, or to consolidate them. So we can see that on one hand, consolidation should address redundancy, right? The first was some shooting or massacre and 3 were dead, 3 were killed, appears in different places here, okay? If we know to tell that each color here conveys the same information, we could maybe generate a summary of 3 dead in shooting, right? And taking each piece maybe from another text. Another aspect, sometimes we have complementary information. Look at the location of the shooting indicated here. It's indicated in different places. We'd like to know that all these pieces of information answer kind of where was the shooting, and then maybe we can combine them together in the summary and put together complementary information. And finally, when you have multiple texts, as we all know, sometimes they'll have contradicting or conflicting information, right? Like one text that 4 were injured, another says 2 injured. Maybe we're not sure which source is better, and we would like eventually to say that how many were injured. According to one source, it's 4. According to another source, it's 2. And especially with viewpoints, right? It's not necessarily the text would contradict. They might be not contradicting, but really reflecting completely different viewpoints, as illustrated here. You can imagine a person referred by these 2 different ways, depending on the source, and we'd like to reflect such conflicting views in the summary. So I think this motivates why it's not enough just to do kind of crude summarization of picking some information from here and there, but we should really worry about more fine-grained consolidation. So just to give a hint of the approach, because I'm a bit running out of time, so we said it's desired at a minimal level. The approach we would like to take, this is just an illustration, is somehow ignore what's here on the edges, but the idea is to somehow decompose the text and links them. That's decompose the text to minimal units and link them. And I should mention that such approaches were attempted, not much, but in a few papers they were attempted in the literature. Okay, here we see something based on AMR, decomposing text by AMR, abstract meaning representation, kind of a prominent semantic analysis framework, and there was an attempt to use AMR for summarization. However, if we would like to take such approaches and use some, right, so what people did before and what we might decide to do following the motivation I mentioned, is take some semantic representation, use it to decompose the text, and then generate summaries based on that. But as we all know, kind of traditional semantic summarizations like AMR or others don't succeed to gain much popularity. They are typically based on some predefined linguistic schemata that are hard to understand, extremely hard to annotate, so they are not very portable because you cannot generate a new corpora for new languages or new domains. And they are to some extent arbitrary, and you really must be an expert in order to understand what's going on there. So we decided to follow another paradigm, which is the paradigm of open semantic representations. So I assume many of the people here heard about OpenIE that would take a system, would take a sentence and break it to triples like John ate an apple, or Ido read a book, etc. Like subject, verb, object triples. We decided to follow a more elaborate approach that was introduced 4 years ago by a group in University of Washington, the group of Luke Zettelmoyer, that's called QASRL, question answer semantic role labeling. And the idea is to decompose a sentence or predicates to identify the relationships, like people familiar with semantic role labeling, identify relationships between predicates and their arguments, like minimal statements, by way of letting people, annotators, ask questions. Okay? So you take these questions, Obama was born in Hawaii, and then you mark born as your target predicate, and you let people ask questions like, who was born somewhere? Obama. Pose the question and answer them. Where was someone born? Hawaii. Okay, so this is given by people. This task can be crowdsourced in large scale. And then you can develop a model, and there's already an operational trained model for this task, that can generate these question-answer pairs automatically. Okay? What we decided to do is actually, and I'll just do an illustration, look at this sentence. These are the question-answer pairs that QSRL would cover. QSRL for now covers only the verbs. We extend it to cover everything. So we have a question about the boats, right? Where were the boats from? Iranian, right? What kind of tanker? An oil tanker, okay? So by this way, we can actually decompose the meaning of this sentence to 7 question-answer pairs, okay? If you read these 7 question-answer pairs, you got the original information from the sentence. But the nice thing is that now we decomposed it. And we decompose it to actually question answers that are natural language expressions. They can embed it, I can run BERT of them, etc. Okay, but I managed to decompose the sentence. And then once I've decomposed sentences, assume I have 2, and each of them, so I can link them. I can, for instance, do coreference resolution and identify that boats are vessels. So cross-document coreference resolution is an important task here, but it's a known task. But what I can do next is I can decompose each of them to its question-answer pairs, right? This is done for each sentence. And I can say, okay, the information here that says that the object that was intercepted is a tanker is equivalent to what does someone attack, a tanker, right? It's the same question-answer. I don't need to provide this information twice in the sentence. In the summary, these are links. And maybe here is a more interesting thing, because here you see it's summarized as attack, while here it's more detailed. It's attempt to intercept, right, which is a form of attack. So I know that these 3 question-answer pairs that say that the boats attempted to intercept something is equivalent to the boats attacked something. Again, if I manage to do this kind of coreference between subsets of the information in this text and in this text, I know what's redundant, I can tell what's complementary. Okay, so that's the general approach, and then you can take these 2 sentences, right, decompose them, link them, identify that maybe this is the same information, this is the same information, and eventually choose which question-answer pairs you want to summarize. So this gives you a flavor of the general approach that we are following, that on one hand tries to decompose text like traditional semantic representations try to do, but instead of doing this using kind of these hard-to-scale approaches, we use an approach that is crowdsourceable, that decomposes actually to natural language pieces. Okay, I don't have to move to a formal framework. Everything is question-answer is natural language that both people can understand, and also now with embedding systems, we can also represent, we know we can represent quite well. So that's our approach, aiming that in a few years, hopefully we can provide a more profound, a stronger basis for getting better summaries. Okay, so that's pretty much it, and thank you.
Thank you, Ido. We have time for one question.
Please answer my question. Is the process of generating something is automatic, or it is interrupted by interactions?
You were asking whether the process of generating the summary is automatic or guided by the interactions. Yeah, so the way we view it in an interactive summarization is that you first generate some summary fully automatically, and then you let the user interact. I showed one mode of interaction, these queries, and the interaction guides how the summary gets expanded in each iteration. So the interaction guides the evolution or the growth of the summary.